All right, looking at number 16 from the Unit 5 review. So I got to deal with all these exponents. So remember, anything with a negative power has to switch from the numerator, denominator, or top to bottom. Anything to the 0 power is 1. So if I kind of take this in pieces, the c squared comes up, the 3 to the second comes down, the a to the 0 is just a 1, and the b to the h stays up top. I can simplify a little bit more by multiplying out the 3 squared as a 9. I'm looking at number 17. We have 2 to the x minus 3 equals 8. Okay. Go back and fix that. 2 to the x minus 3 equals 8. And this is an exponential equation, so what I need to do is get the bases to be the same. 8 can be rewritten as 2 to the third, and once I get the bases the same, I set the powers equal to each other. Okay, and then I add a 3. Coming up here, x equals 6. Number 18, consider this function. Find the range. Okay. So y equals 25 times 0.2 to the, oh, it's a little sloppy there, I know. Let me see if I can rewrite that. Hold on. 25 Alright, so now then they give me some domains, which are basically inputs. Okay, so they give me like -2, -1, okay, 0. Okay, and they give me a couple other ones. Alright, so we just got to plug these in. Okay, plug these into the function. So I'll do these first couple here. And so when I get basically f of -2 okay, equals 25. Sorry. Equals, let's say 25 times 0.2 to the -2. Okay. And I'm going to need to enter this into a calculator. I'm going to say 25 times 1 over 0.2 squared. Okay. So then I punch that into a calculator. All right. And when I do that, I'll grab a calculator here. 0.2 squared is 0.4. So this equals 25 times 1 over 0.4. Okay. And then I'll do 1 divided by 0.4. That's 0.25 times 25, and that equals 62.5. And then I would just do that for all the other inputs. Just plug them in, and work them out. You can do a lot of that on a calculator. Okay. For the second part, it says, as the value of the domains increases, the values of the range increases. Okay. So when you look at it, the numbers actually get smaller as the x's get bigger. And if you look at the reason why is this value right here, our growth factor is less than 1, so they should be getting smaller. Okay. Okay, let's go to the next one, number 19. And this says y equals 7,000. Okay. Well, it says you borrow $7,000 at 2.5% annual interest rate. And how much will you have after 3 years? Okay, so I'm going to set up my function. So this is my initial amount, 7,000. And then remember I have to add a 1 to the interest rate. So it was 2.5%. I had to move the decimal spot 2 spaces to the left and add a 1. And they want to know after 3 years. Right? And so then I plug this into a calculator, and when I do that, I should get 7,538.23 right, if I plug that into a calculator. Right. Number 20, they want to know how this is translated. So if I have 3 right here, okay, and then but I really started with this one. They want to know how this translates, right? So remember, when I add something directly to the x, it moves me left or right. If I add it to the whole value, that moves me up or down. So it's kind of going back to like our absolute value. Remember this, if I had something like that, that moved me to the right. If I had something like this, it moved me up or down. So this one is going to go up 2 spaces. Up 2 spaces. 21. They want us to find the common difference, right? Or common ratio, depending if it's linear or exponential. We got to figure that out, right? So we have 1, 3, 2, 6, 3, 9, and 4, 12. Okay. So I'm going to look at the y values, and I increase by 3, I increase by 3, and I increase by 3. Well, since they're all increasing by the same amount, that is a linear relationship. That is a linear relationship. Okay. And so I would write that as a function, which is the second part, is it's going to be y equals 3x. Not to the x. That's exponential. Okay, this is a linear one.